I'm very honored to have been invited to speak to you, to address you as a guest speaker. This day is a very important day in your life and the life of the family. You gave some indication, Claude, about my background. What very few people know is that actually I started to do regular meteorological observation when I was 9 years old. I was very incredibly lucky to live my passion from childhood to the top of my profession, and I appreciate it has been an incredible luck to be able to do that. I did some scientific studies, you mentioned them, and the emphasis was on mathematics and physics. This is very important if you want to deal with climate and meteorological issues, but not only. I studied also economics, I studied music, I studied enology, many other things. And the reason why I mentioned that is that for me it gave me foundation for dealing with multidisciplinary issues which are getting increasingly important in the modern world. So the message to you is that you can live your passion. You don't have to give up your passion for doing something. You can live your passion until the end of your life. And meteorology for me was a fascinating field. Why? Because I was both fascinated, maybe I should say even obsessed with meteorology, and at the same time I wanted to deal with something which had an impact on the life of everyone. And meteorology is a sort of ultimate applied science as it affects everyone every day. You mentioned, Claude, that I was head of the forecasting branch of the French Met Office for a few years. And it's fascinating because you are a scientist doing an experiment every day. And this experiment is judged not by your peers, it's judged by the public, it's judged by everyone. So you are confronted with this evaluation by everyone in the world every day. And this is a fascinating aspect. Meteorology and climate, it's Jarraud's book about a short, brief history of time. I'm going to, in French, time and weather is only one word. So I'm going to do a brief history of weather. Weather and climate have been major drivers of human evolution from the beginning. Actually, from the migration of Homo sapiens out of Africa. It was a key element in the development of the great civilizations of antiquity, be they in Europe, in India, in China, in all parts of the world. But there were also, climate and weather were also elements for the failure, the decay of some of these civilizations. The fluctuation of weather for most of the time where Homo sapiens has been on this planet were associated with deities, with religion, because people didn't quite understand what was the reason for this. So you cannot imagine the number of names of deities which are associated with the weather in all parts of the world. So in other words, it was not really a science until pretty recent time. The first attempt to turn meteorology into a science goes back to the ancient Greeks, and one of them in particular, which I'm sure you're familiar with the name, Aristoteles, at the first attempt at trying to understand the mechanism and try to understand what could explain this variation in the weather. But the key change happened in the 17th, 18th century. In the 17th century, we saw the development, the emergence of instruments, thermometer, barometer, and a few others. And at the same time, there was a scientist called Descartes, you probably heard about the Cartesian Approach, who tried to rationalize how we should deal with the scientific issue. And in particular, to say we have to base science on facts, on observations, to discover the basic laws of nature. And meteorology is all about that. It's about observation. It's about using the fundamental laws of the mechanics and the physics. But the observation they have to be made with very strict protocols, wherever they are made, be they in Latin America, in Asia, Africa, doesn't matter. They have to be made with the same standards, with the same protocol, so that they can be compared, they can be used together. We have to rely on the fundamental laws of physics. And meteorology is a science which has been, when I say meteorology, I often mean also climatology, and I will explain to you why in a minute. But meteorology has been boosted by the technological development all along the 19th, 20th, and now 21st century. Telecoms. The key invention to be able to do weather forecasts was the invention of the telegraph, the electric telegraph, because that allows for the first time real-time exchange of data across all the countries in the world. Computers, supercomputers, you are all familiar with that. At the end of the Second World War, the very first application of the very first supercomputer in USA, the ENIAC, was weather forecasting. And of course, what we call supercomputer at the time, there was less power than in your watch now, but that was a supercomputer at the time. Satellites, we have satellites observing many, many things now. So what I want to say is that this is what we call big science. This is at the leading edge of using all the technological development. And that leads to huge progress over the second half of the 20th century, both in terms of monitoring, but also in terms of modeling. And that translates into predictive scale. And science is something which transcends, which goes much beyond all possible cultural and political differences. And I'll tell you why I think this is very important in the current world. Climate, I said climate meteorology are very much linked. To a large extent, you can think of climate as the average of weather condition over long periods. And in the past, I'm sure you heard skeptics saying, yeah, but why do you worry about climate change now? There were much bigger changes in the past. Yeah, sure. But what were the reasons for these changes? Tectonic movement. The continent were not with the same shape, the same place in the past. But we're talking timescales of millions of years. Other parameters are the parameter of the orbit of the Earth around the Sun. It's not a circle, it's an ellipse. This ellipse is more or less elongated. Then the Earth is turning, but the angle is not constant, it can change. And like the toy for children, it does things like this. All that explains the transition between ice ages and the warm periods like the one we have now. And what we are talking is periods of tens of thousands to hundreds of thousands of years. Solar activity, some people say that, yes, the solar activity is changing, but it cannot explain what we see now. Volcanic activity, yes, but for a short period. And now, and this is the most important, now you have human influence on the climate. So how do we know about climate in the past? How can we be so sure about climate in the past? Well, we have many things we can use. You can get a lot of information from historical records, books, paper, many things, but that doesn't get us very far into the past. So you can look at other things like tree rings, you can look at sediments, you can look at things. In Antarctica, you can drill ice cores. And because there's so much ice and the ice is so old, you can go back in time about 800 to 1 million years ago. And in the ice, you have little air bubbles which are trapped. Now, this air is fossil air. It's the air which was trapped at the time the snow was falling. So you can measure the concentration of greenhouse gases with the most modern instruments with incredible accuracy up to 1 million years ago. That's why we can tell you the concentration we have now, we have never observed that for at least 1 million years ago. So the greenhouse gases, you heard the word. You know what a greenhouse is. The greenhouse is the fact that the sun is coming to through the glass of the greenhouse, and then it's reflected back as infrared. But the problem is the infrared is trapped by the glass, so it stays in the greenhouse. It's the same in the atmosphere, but it's not glass. It's molecules like carbon dioxide, CO2, like methane, and a few others. And we started to get worried about the impact, the increase in concentration of greenhouse gases in essentially in the 1970s to 1980s. But there were huge, at that time, uncertainties, and many scientific questions were still open. So we held a number of big conferences. I know some people say these big conferences, they are a waste of time. No, sorry, I'm sorry. The first World Climate Conference held in Geneva led to the creation of IPCC, which is now producing these authoritative reports every 6 to 7 years. It led to the development of the World Climate Research Program. And the IPCC, I will say a few more words about it, has so far made 6 assessment reports, which are the authoritative state of knowledge about climate change. Now, IPCC, you heard the name. It's until recently, it was a unique process. Now, some of the process have got inspiration from that. It's not a research group. It doesn't do research. IPCC just does the evaluation of the state of scientific knowledge about climate change every 6 to 7 years. You talk in your introduction, Claude, about uncertainty. Very interesting. I will come back to that because I fully agree. Uncertainty is something we have to live with. But the IPCC report not only tell you what we know, they also tell you what we don't know. They give you levels of confidence. So they state what we know and what we don't know. They take into account all available scientific, available literature about the issue. It is policy relevant, so it's supposed to inform policy decision, but it is not policy prescriptive. It doesn't tell what we have to do, but it tells if we do that, this is going to be the consequence. It is unique also in the sense that it is approved by governments, but if there's disagreement between governments and the scientists have the last word. So think about it in the UN system. It is an intergovernmental process where the government cannot change the scientific substance. They might be able to change the summary, these things, but the facts cannot be altered. And if there's disagreement, the only thing government can do is to put a footnote, which can be very embarrassing for them to say we disagree with this fact, which is solidly established. So they cannot basically disagree with that. And it has been an essential foundation for the negotiation under the United Framework Convention on Climate Change. I understand you will have a conference by the somewhat senior person from the UNFCCC in the autumn. So where are we now? Where we are now is that some of the news are not good news, really. Concentrations of CO2 are the highest in at least 2 million years. The sea level is rising faster than at any time during at least 300 years. The retreat of glaciers all over the world are unprecedented since at least 2,000 years. Arctic Sea is the lowest for at least 1,000 years. And if you look at the global temperature, the last 7 years are the warmest since we have modern records, in other words, since the beginning of industrial period. Think about it. What we call now a cold year over the last 20 years, a record cold year globally would have been a record warm year in the last century. So that's what it is now. The climate has been changing. Many temperature records are broken year after year. You are coming from all parts of the world. I'm sure all your countries have experienced these things. We have seen an increase in the intensity, the frequency of extreme events, heat waves, droughts, floods, whatever you want to name. So how can we be so sure that this is due to human activities? Well, because of the IPCC reports. And the explanation would be a little bit long, but let me try to give you a very short explanation, a short clarification. If you take the most sophisticated models of the climate, there is no way you can reproduce what we have been observing without including the human factors. If you ignore the human contribution to greenhouse gas, there's no way you can reproduce what you observe. But now we go further. We can often say some of the extreme events you see would not have been possible without the climate change. So this is a new branch of science which we call attribution science, and this is now very, very solid science. So we have the knowledge. We cannot plead ignorance to have to do nothing. So ignorance cannot be used as an excuse for inaction. And because it is based on facts that you cannot challenge, climate change is not a matter of faith or belief. Sometimes when you have journalists, I don't know whether there are some journalists in the room, they ask you, do you believe in climate change? And say, sorry, that's a wrong question. It's not a matter of believing or not. It is there. What you can do, where there are uncertainties, is what is the impact? What should you do about it? What should be your reaction? But it's not a matter of believing or not. Urgent action is necessary, both for mitigation and adaptation. What is it? Mitigation is about reducing the emission of greenhouse gases to a level where we can adapt to the consequences. And adaptation is about adapting to what you cannot avoid. So there are many challenges for taking action. One of them is the fact that there are many disciplines, many actors involved, and all with different perspectives. There are very different languages used by the scientists, by the decision makers, by the negotiators, by the political people. I'm not talking English versus French. I'm talking the fact that we all use our own jargon, and it's essential that we just adapt to the language of the others. We have to make decisions, back to the introduction by the Chancellor, uncertainty. We have to make decisions in a context of uncertainty. And these things, it doesn't mean that you know nothing, but you know about probabilities of scenario, you know about things, you have to do that. The past is increasingly misleading as a predictor. You cannot use the past as a predictor for the future because of climate change. And many people have difficulties to take into account long time scales. You see, a politician, his decisions time scale will be driven by the election cycle, for example. But here we have to think about the consequences in 50 years, in 100 years, and that's not always easy to see. When you talk about sea level rise, actually we're talking about time scales of hundreds of years. So there are different cost-benefit analysis. In a few countries, people saying, I want to make my country great again. I want to focus on my country. No, we have to focus on the planet. No country can do it alone. We have to balance the economic versus the social, the environment, cost and benefits. Benefits in the future versus investment now. We need to take into account the demographic parameters, the urbanization change. And don't forget, a non-decision is a decision. So you cannot say, I don't decide anything. So sorry, if you decide to do nothing, it is a decision. So we need to do many things, and we need also to have changes in the governance of the system in many areas, because the traditional ways to deal with it are no longer suitable. For example, in the UN, many organizations are thematic organizations dealing with themes. We have a cross-cutting issue. We need to deal with that as well. But there are some very worrying trends across the world. One of them is that in many countries, you see a resurgence or a strengthening of nationalistic trends at the expense of global solidarity. The short-term considerations tend to prevail at the expense of longer-term consideration. Scientific evidence is sometimes ignored at the highest level. You saw an example just a couple of days ago with the decision of the Supreme Court of USA about climate change. It was taken with a majority of 6-3. Now, I can bet, I'm sure that the 6 people who took that decision, none of them has taken the 5 minutes to read the summary of the IPCC. So decisions are taken ignoring the scientific evidence, and that's a great danger for the future. There's a tendency to blame the others. No, sorry, we have all a role to play in that issue. Growing individualism. No, sorry, we have to deal with that in a collective way. Refusal to accept or even to listen to the point of view of others. And this trend, this is something which is even more critical for your generation. This trend is reinforced by social media, because you belong to groups, and these groups feed you with information which comforts you into some of your preconceived ideas. No, we have to be as open-minded as possible. But it is very difficult, even for the top decision makers, to be able to distinguish between what is fact and what is fake news. And that's a challenge that we cannot ignore. But there are also some encouraging trends. There's an increasing involvement of the civil society in general, of young people. Your generation, you are going to play a much bigger role. You are amongst this young generation. You will be in leading position in the coming years. Please, do not become old too fast. Stay young, please. So that's one of the messages. But we also see a change of attitude of some major actors. Pension funds who decide to de-invest from fossil fuel, some foreign funds, some big private sector actor. It is also, this issue is increasingly present in democratic debates around the world. There is a much less denial by what you call the deniers, the climate change denial. There's a stronger acceptance, despite what I said earlier. In general, there's a stronger acceptance of scientific evidence. And I found that very, very encouraging. And this is due to a very large extent to the very solid review by IPCC. But also, some extreme events, as I said, can already be felt. They can be attributed to climate change. Some lessons have to be learned from other crises, like the pandemic crisis, like the consequence of other crises, such as the war in Ukraine. So, is it too late? No, it's not too late. Have we lost the battle? Which battle? If we consider that the target is to limit global warming under 1.5 degrees globally, yes, probably we have lost that battle. But we have not lost the battle of 2 degrees. And do not forget, 2 degrees will be worse than 1.5, but it will be less bad than 3 or 4 or 5 degrees. Have we lost the battle of delivering on the SDG? No, but we have to accelerate the action we take. But climate is a lot more than temperature change. It's about, for me, what keeps me, prevents me from sleeping overnight, even worse than the temperature change, is the impact on the water cycle, with the impact on drought, on water availability in many, many countries. So it is never too late for the to avoid a situation to become even worse. It is possible that some tipping points will happen, like the melting of the Arctic ice. It's something which is very likely now to happen every year in the next 20, 30 years in the summer. But giving up is not an option. Business as usual, if we do nothing, implies a change of 3 to 4 degrees on top of what we have now. Now, some people may say it's not much. Keep in mind that the difference between ice age, when there were 2 or 3 kilometers of ice here in Geneva on top of us, and a warm period like now, it's only 5 to 6 degrees globally. So 3 to 4 on top of a warm period is serious. There is absolute urgency to act because the end of the century is tomorrow. So let me conclude. We are facing a unique situation. Our planet is unique. Ban Ki-moon said there's no plan B because there's no planet B. A fundamental principle should be global solidarity. And failure to act will ensure failure for humanity, not for the planet. The planet will keep on turning around the sun for a few more billion years, but it's failure for humanity. So it is a global issue. No country can do it alone. No one can do it alone. Everyone has a role to play at all levels. So success in addressing that could also be a lesson for other major crises. So sorry I was a little bit long. Thank you very much for your attention.